tend to speak very fast, but I try to speak slowly. Let me start by saying that do you hear me? Yes. I'm very pleased to be here. It's my first time in Mongolia. Actually, my second day, my first day was amazingly interesting. For sure, it's not my last time in Mongolia. And I'm very happy to be here because I think there is a lot of possibility of collaboration in this globalized world, where more and more there is a need for collaboration and everybody bringing our own culture and interest, finding ways to collaborate, in particular in science and autonomy. So I've been working on this, my talk is on big data and open data. I've been working on this topic for like 30 years. But in the last 6-7 years, I've been getting involved in open data, which I consider one of the most interesting research topics in the world now. It's interesting for two reasons. Next slide. Next slide. For two reasons. Number one, because data is going to be the main game changer in the world. We are at the beginning of a big change which will last 20, 30 years. In Europe, many years ago, we had the Industrial Revolution. It lasted 80 years, in the 19th century, 18th century, 19th century. And now it's going on, now it's going to be even faster, even more impact on the world. Data basically is really going to change the way we live, the way we collaborate, the way we work. Simply because everything that now so far was made was manually, not going to be done with the help of computers. If you think about it, 6-7 years ago, 10 years ago, less than 10 years ago, Facebook, the big American players, Google came around, and they created what I usually call the virtual world, the virtual reality, internet. But that moment of change is now over. And now, in the next 6-7 years, there'll be another big change, which is what we usually call smart city. I like to call it smart city society. And in this big change, what's going to happen is that the real world, where we live every day, and the virtual world, the internet, the Facebook world, the Google world, are going to align, which is in the same time, in the future, we'll be living in real life with our phone or watch or whatever, connecting us in real time to the world on the topics on what we are working on at that moment. So we could be traveling on a bus. While traveling the bus, we could check in real time the situation of navigation of the traffic everywhere in Ulaanbaatar or anywhere else. The situation of hospitals being open or closed, or so on and so forth. So the key point to the change now that data are going to provide us a new way of living our world. It's going to be all all our way of living the world is going to be mediated by computers. Next slide. And data are going to be the main game changers, and this is why I discuss now this idea of open data and public data. If you think about it, there are many kinds of data. There are your personal data. There are your medical records. There are the data of the companies who provide services. So, for instance, the transportation utilities, they know where we go if they give us some kind of pass. Restaurants have a record if you pay with a credit card of us living there. They can keep record of our menus. Now, all those data are important, and this data, the kind of company data, are going to be important because the companies are going to change, in the private sector, going to change the way it works based on their own data. They're going to change the way they're going to produce data so that they're going to produce a better service. Okay? But all of these data coming from the private sector are going to be interconnected, mediated by the data from the public sector. So if you think about it, a restaurant owner may know everything about the kind of menu he's offering, but he doesn't know of the streets. He doesn't get data about the streets. He doesn't get data about the traffic. Where are these data? These data are data which are owned by the public sector. So in Europe, for the last 10 years now, we've been pushing this idea that the public sector should make data from the public available to everybody, because not only for transparency reasons, which is what you usually people do, but because this data about the geospatial information, the data about the weather, the data about transportation, are those data which are going to connect and provide the infrastructure which is going to enable the new second generation, the new generation services, where the private sector can then build better business for their citizens. And so this is why I really put this idea of public data. This is why my talk today is going to be on public data. I can do it myself, great. Now, there is another issue. I'm going to talk about data, but of course, I did not invent data. Google invented data. Facebook invented data. I kind of don't like the way they work, but the point is there. If you think about Google, if you go like to Google Maps, for instance, you say Google Maps and the head in Google Maps is data about more or less a lot of cities and places in the world, but they all present the same information about all the places. So if you, no matter which city you go in Google Maps, or like even in Facebook, you all get restaurants, you get streets, you get all those things which are common everywhere. So restaurants are everywhere, streets are everywhere. But for instance, in Trentino, it's ski slopes, because people ski. There are no ski slopes in Google Maps. Here we have nomadic tents. People live in nomadic. There are no nomadic tents in Google Maps because they are not common enough for them. So the point is that in the new generation of data, you need to generate each actor their own data which represent properly what they are locally. This is what I mean. So we, like in Italy, in Europe, we represent data representing Europe. You represent data representing Mongolia. And this is going to be exactly why we're going to go beyond the state of the art, what they call the Web 2.0. We are going to relate to what in Europe sometimes we call the Web 3.0, which is really pretty much smart cities. And the key difference is that those data are going to be local. The data about Ulaanbaatar, I'm going to talk about what is running in Ulaanbaatar now, and which is maybe not running anywhere else. And in Ulaanbaatar, there are restaurants as in Italy, as in Trento, as in Europe, as in the US, and this is going to be common to everybody, but a bunch of data which are locally only here. And this data, by the way, is what is going to make the value. Because, for instance, in Trento, we have a big touristic industry. Good. All these tourist data for are important. Google doesn't care about the data. We do care, and we push a lot of money for making those data very high quality. In Ulaanbaatar, maybe have the mining industry, maybe those data become very important, and so on and so forth. So the issue, the first generation is not only we should all make our data available, but we should also make sure that the data represent what we are, each of us locally to our culture. And then, as a first step for coordination. Because we can now come to the scenario where you can think where, like in Ulaanbaatar, people develop their own public data, in Trento their own public data, but then some friends from Ulaanbaatar come to Trento, and they can participate to an event, or vice versa. I come here, and they participate to an event here. It would be very great if my ID as Fausto Giunchiglia giving a talk now could be the same ID to Fausto Giunchiglia, Professor at University of Trento. Because at this point, simply by querying me, you can go there and you can get into my web page and get in real time on the data. So you see, it's going to be the vision that we foresee is a vision where we all build bottom up our own data representation, and then since the world is global and since we collaborate, we mutually create collaboration through linking data. So there are two levels of linkage: local linkage, so that we present Ulaanbaatar as it is, with the strengths, weaknesses, whatever what it is, and by the way, try to do the same, but then we jointly create the map of collaboration through joint entities, joint people traveling, events, and so on. So this is really, and I really see this bottom up. I believe that the Web 3.0 was a bunch of American companies taking the leadership and basically much better than everybody, including us in Europe. But I believe the next generation of data, the next generation of advanced IT services is going to be the successful ones will be bottom up. Because to build a smart city, if you think about it, Ulaanbaatar smart city is going to be a different smart city from Trento smart city. It's going to be a different smart city from Rome smart city. So we have a big opportunity now to build this our notion of smart city in a way which preserves and enhances our features and puts us in the globalized world. So this, I think, is actually the key point of the work I do now, and this is the vision. And also, this is also why I'm here, also because I really hope that we will be able to start bottom up, maybe collaborate, so maybe like Trento Ulaanbaatar will be the first nodes, plus others, and around the globe, we're going to start a new game. So we don't get someone else from anywhere else to run our own data, but we run our data and we build together collaboration in this network world. Now, this is the vision, but there are a lot of problems, a lot of difficulties. We call it 5 difficulties, and we'll now go through them, all of them. Number one is volume. You see, big data, everybody thinks that big data means a lot of data. There is nothing more wrong than that. Big data, lots of data have always been around. There are lots of data anywhere. I mean, take like the utility companies, who have like, take the medical records, your record for 20 years. This is big data. So big data means more than just volume. It means that the volume creates problems that makes it hard to create data. And by the way, volume is only one of the 5 V's. Now volume here, and this volume means lots of data, and this is where a lot of research is being done on issues like NoSQL, schema-like databases. The second one is velocity, what people call velocity. Right now, since we have sensor data, which allows us to get streams of data in any place, you get the continuous stream data. And by the way, these streams of information are going to change everything. I'm going to change the way we teach. I'm going to change the way we do engineering. So when I talk to my colleagues in the Faculty of Engineering in my university, like the civil engineers, they tell me how hard it is to get data, for instance, about the environment, about pollution, how hard it was. Now it comes immediately. You just put the sensor every 20 milliseconds, you get the new data. But this poses a challenge of what do I do with so many data, right? So this is the second challenge. And by the way, let me say that volume and velocity are the 2 areas of research where there is a lot of research being done. There's actually a lot of areas where big data people have put a lot of effort. For instance, there are available, like in MongoDB, there are available schema-less databases which allow you to store terabytes of data. And then there is diversity, which is the one I like the most, devices, right? Variety. What is variety? Variety is the fact that if you think about IT has been developing in the last 20 years, we have if you think even in the university, we have a database for personnel, we have a database for teaching, at least in Trento. We have a database for research records, we have a database for project records. And by the way, you know what is common? That in all the 4 databases, there's one guy called Fausto Giunchiglia. But you cannot connect them. Because the database on the research records is, maybe it's not Fausto Giunchiglia, but it's called Fausto Giunchiglia. In the other, it's called Giunchiglia F, and so on and so forth. So the point, and the schema is different. So the point is that at the current state of the art, it simply is practically impossible. There is no generalized technology which would allow you to take data from different databases and integrate them. So for instance, University of Trento to produce only one ID, which is Fausto Giunchiglia, who is at the same time a professor, a teacher, a researcher, a guy who is traveling a lot. So here is the one theory that we are now implementing University of Trento as a game changer. So anytime, so I don't know what happens here, but in Trento we have a pretty active international collaborations. So anytime some professor comes around from abroad, we get an email from the president saying, we need to know immediately by tomorrow who knows this professor, or who collaborate with those university, and we often inform 200 times, right? Because, and So we want to make sure that by simply unifying all the records of the travel, the research, co-authors, whatever, we will make a simple field that any time the professor comes in, with one field, we want to know all the professors and students in University of Trento, which has all the collaborations with them. But this means integrating all the data sets, all the databases in the university. But this is exactly the project we're doing now. And this is exactly where the variety and diversity from. Because it's exactly where we can deal with the fact that in the different databases, the same information, like me, is represented in different ways. And by the way, I put this in red because I believe, not only me, but for sure also me, I believe that this is the one game changer, the one not only blocking factor. Because since we don't have the technology, and so everybody knows, the state of the art now in data integration is so that is very costly. You have to do it every time from beginning, from scratch, and it takes a lot of time. Any single data integration task, even with state-of-the-art technology, data warehousing, takes between 3, 4, 5, 6 months, with like very many years of work. And then veracity. Veracity is the fact that if you think about it, any data, when you store data about a phenomenon, the moment, suppose now you just have a data, a sensor which measures the air pollution. You store the data now, 10 seconds later the data is obsolete because the work evolves, keep changing. Or sometimes you ask you ask information to someone and he gives you wrong information. And so on and so forth. So veracity is a property that not only a problem for variety in integrating data, but also those data tend to become obsolete and tell wrong things almost immediately. So there's not only an issue of integrating data, there's an issue of how do I keep this data up to date? How do I know instantaneously that the state of the roads in Ulaanbaatar rather than in Trento? So veracity has to do with the problem of making sure that the data are as good as possible representation of the world. And this is where, this is actually the second topic of my group, the research group, which I consider very strategic. I do believe that the first two are important, but the state of the art is already good enough. I believe that variety is the biggest problem, but I also believe veracity is a crucial problem. And this by whether the technology that people are doing is what people call crowdsourcing, which is let us people to help us maintain data. So let me give an example. In Trento, we have an open data project, and the public administration produces all the open data about transportation. You can go to the website and see them. But suppose that now something happens, like there's a big hole on the street. The public administration will know in 1 week. But anybody going there and passing by will see the hole in the street. So you can make a simple app where say if you see a hole in the street, please send me a message. You crowdsource. A lot of dynamic data, a lot of data about the real-time state of the environment can be best managed by people. And this veracity. So in this way, we can use the voluntary work of people as a way to maintain data up to date. And this is a fifth problem. And the last problem here is vulnerability. I actually call it privacy. But vulnerability, when you have to sell your material to look nice, and 5 VB is better than 4 VB. But anyhow, in the early days it was 4 VB. Anyhow, vulnerability, what is the issue? The issue that for anybody, as we have done a lot of experiments. It's really, the issue of privacy is really becoming terrifying in the sense that it's rather impressive the amount of information you can have about people. I think most of you, I don't know, if those of you have Android or iPhone, if you turn on your localization services, if you allow Google to take your GPS information, I hope you understand that pretty much everything we do, can be checked simply by deciding where you are. Let me give you examples. If Google takes your position 3 times in a row at midnight, Google knows where you live. 3 times in your life, right? Google takes information, or like smart retail, if you take information on what you buy in a shop, medicine, Google knows what you're sick of. If Google knows that you're here, it knows that you're in an event, and most likely you're a professor or a student. So spatial information, spatial table information plus data is really one of the most terrifying things which is really happening. I mean, I don't know if you've seen here, but there was a big issue that the Americans have done this experiment. They have like monitored the phone calls of all the Americans for 1 year, and they came to know everything about Angela Merkel. There was a big scandal in Europe about this. But basically, they were able to identify 280 million people simply by logging phones and position of the people. And I know the people have been working with the people who have done this. When you see this data, it's much more terrifying than you think. So this is why privacy is becoming important, and this is why I believe that the issue of privacy must be dealt with, not a posteriori, but you have to have some policy that we call privacy by design, by which not only you make public data, not only you do data integration, but by design, you design technologies which will allow you to prevent things to happen. Because right now, if you think about this, Google knows everything about us, Facebook knows even more, the Secret Service knows everything, but that's okay. But that's not being always the case. So, but if you think about it, there are 10 organizations in each state who know everything about us. But in 10 years from now, the public transportation service will know everything about us. The restaurant people will know everything about us. So not only people will know about us, but there will be lots of people who know about everything about us. And these problems will become explosive. So this is actually where we now started the project where we call it privacy by design, now, years ago, where not only we work on the data correlation, but we think of techniques by which the data owner, my own data, I'm in control of what people do by own data. Europe, there is a strong regulation for this, where actually people complain a lot because in Europe we're much stricter than the US, and people say that this stops business, because you see there is a tension between the more I know about you, the more I can provide services, but the more I know about you. So my usual example is that, of course, if I am sick, if I have some illness, I don't want anybody to know about this. But if I'm in a place and I feel sick, I would like to know everybody to know about this so that they can get to the doctor, right? So the issue is how you really, not only you come to a new big data, big open data, big data management, my design together with the data, the ways to use them so that on one side there is a tension, on one side you protect people privacy, but on the other side you allow people to maximize the possibility of exploiting the powerful power of data. So now these are the 5 E's. Pretty much in my group, I have a pretty large group. We use state-of-the-art technology in the first 2, and we work on the last 3. But in this today talk, I'm going to concentrate only on the veracity one, which I think is the most fun. And also I think is like privacy is going to come, but I have 2 or 3 or 5 years to work on this before we're solving the problem. And also veracity, well, you can do veracity, but first you need to have the data integrated, and then we're going to concentrate on variety, which is the problem, how we integrate data coming from different sources. And if you think about it, the way we think about open data, I'm giving an example here. So you see, as I said, when you do data, you do open data, and this is an example, you have to think of which data are best for you. And I usually say that computer science, IT technology cannot teach you to do things you don't know how to do. Actually, if you don't know how to do things, IT helps you to do them faster, which can actually get things worse. But if you know how to do something well, then computer science can help you a lot, and open data helps you a lot. So in Trento, our #1 business is tourism. We are in the middle of the Dolomites. People have been there. It's a nice place. So first we start to open data where we start, from tourism, of course, because this is exactly where we want to compete advantage. And here is a very concrete example. It's a cartoon, but basically Cavaliers is a place in Italy where we go to ski slopes, and then they want to go and eat typical food, as I usually they do, as I do when they come here. Now, so suppose that I want to provide this service. Not that at the state of the art, for instance, in data, we have lots of skills. We integrate all the data about skiing, but they're not integrated with the data of restaurants. They're not integrated with the data of buses. They're not integrated with the data about weather. They are all different sites. Right? And then why? Correctly so, because we have the database managing ski zones, we have the database and the companies managing restaurants, maybe one per restaurant, we have the database and the company managing transportation. They all have their own data. Open data means that they take the data that they are producing anyhow and make them available so that someone can then get integrated. And so that in 3 years from now, in Trento, we will be able to provide a service to the user. So, for instance, a trivial example here is, it's 5 o'clock, the system should be able to tell me that there is a lot of traffic jam. So she tell, okay, I know you like beer, there is a beer open on the right, you go to the left, there is very good Trentino food, go there, and then around 8 o'clock the system should tell me, oh, by the way, now you can go because the street and the road is available. This is the kind of service you have to do. But to do that, you need to integrate data, right? And this is an example. And you know, and you need all this data. And by the way, do we have that data? Yes, of course we have this data. And by the way, if you go to our open data site, I'm going to show you demo data. I hope we that at time. You have this data. We even that this data is open. So we have data about restaurants. We have data set of restaurants. We have data about ski lifts. But by the way, notice that in one data set is called Cavallese, which is the name of the city, but the data set below is called Cavallese-Fondovale Partenza. Maybe, of course, you don't understand Italian, but you see Cavallese is there, right? Most likely the same place, yes, but the system doesn't understand it. Not only that, there are coordinates. So not only why coordinates are important? Coordinates are important. Why? They are important because if there is any restaurant with similar coordinates, I know it's going to be easy to get. Or, and by the way, we have a description of typical food. So if I know if I profile you don't want to use the service, if I know that you like Italian food, it's kind of meaty food, lot of meaty food. And by the way, notice that in these data sets, there are multiple languages. So we have data set where some data are written in Italian, some data are written in English, and since we are bilingual, some data are written in German. So the same word, the same concept is in multiple languages. And this happens to us because of the border with Austria. But think now that I want to integrate the data here with data in Mongolia, then we have to integrate the Mongolian with Italian. So not only people write the same concept in different ways, but they use different languages. This is what we call semantic interpretation. And you see, it can go on, and then later on, you can find that for each, you can find out. By the way, there is another address, there is Via Costa Salici, which I don't know if you know about it. Okay. So you see, there is Via Costa Salici 10 here, and there is a Via Costa Salici Cavalier. This means the same address. Yeah, they put the name of the town, they put 10. Right? How do I know this? By the way, this may seem simple, but we now elaborate in 1,600 data sets, a few 100,000 of data, getting up to the millions. I mean, the variety is huge. Simple mistakes, one by one, they are easy. But to come up with a uniform method from the integrating is at the moment an unsolved problem. But it's very clear that if I could fix all these differences, and I could put everything in a single data set, then I would be able to tell a guy, look here, there's this event, you go there, to the restaurant, and then maybe go and give a beer somewhere else. And they made this experiment, I gave this example for tourism, I could give it for anything. I could give it for health data, and it's the same problem everywhere. It's the same basic problem. Right? So this is exactly the kind of problem, and now the issue is, we are here trying to integrate data. How do we do it? How do we do it? How do we find a general method so that we can really seamlessly integrate data and provide the kind of services, the kind of smart city or smart territory service that everybody talks about. And by the way, and that can be do it faster than the others, because here, dealing with the guys that going faster are going to be the ones, the companies that will actually, I mean, take the market. It's going to be a huge market, forecast of billions of euros. So, suppose this is how we do it. So I'm going to briefly describe, and people, I'm not going to give you a little demo on this, how is our approach to this diversity problem, to this variety problem. First of all, let me just point out, I'm sure you know about this, but that there are, in the open data approach, there are the 5 stars. So when you publish data, you get a ranking from 1 to 5 stars depending on the quality of the data. Oh, by the way, a lot of people are confused because people think that open data are open data that you publish for people. No. You publish open data for machines. You publish open data so that there are data which are easily processable by machines, so that programs and machines can produce better services without human intervention. So the 5 stars say exactly this. So star number 1, and so for instance, yes, I was told also here that in Italy we have this law for transparency that you have to publish data. Right? Yes. What does it mean for you to publish the balance of companies? Publish salaries. But what does it mean to publish salaries? So a bunch of years ago, when people were asked to publish salaries, people put salaries inside the PDF, possibly in within document 100 pages to 50, 100 pages. So the salary is somewhere inside there, but it's almost impossible to find. Right? There are many ways to make data unusable. And star number 1 is exactly as unusable as it can get, which means you put them in a PDF file. You put it in a PDF file, but the first star is you make them in open license. Open license means you make data that everybody can use it. And there is an entire topic with you on this. But PDF can be used by people, but it can be used by machines in an automated way. I mean, it takes a lot of work. Number 2, structure the format proprietary, like Excel. Right? Well, is that good? Yes, because now we have a table. I mean, to have a salaries of when the people work in the university trained on an Excel sheet is better because of a table. Of course, you can still cheat a lot, but you have a table. At least you don't do parse. I mean, parse is very much controlled. But you have the problem there that is not open format. You have to rely on Microsoft tools. Level number 3 here is that you do the same as level number 2, but on open form, like CSV or JSON. Right? Style number 3 is actually becoming real now. You have data in tables formatted in a format which does not require any proprietary access to use them. But at this point, at this point in number 3, we are still at the step where we were with the guy in the data, in the script guy, the Turing guy. They are still data in tables. They are just separate data that come out of the database. Style number 4 says that you have to get to the RDF format, which is the standard format for the semantic web, for the open web. But what is more interesting, 5 stars, means that there is Fausto Giunchiglia in the data set in Ulaanbaatar, National University because of today. There is an idea which says that Fausto Giunchiglia here, and the same Fausto Giunchiglia is also professor in University of Toronto, which by the way is also professor. The Fausto Giunchiglia is going to be somewhere in Switzerland in June, Monday or next week or Tuesday in Brussels, and so on. This is actually the kind. So, and this now goes back to what I said at the beginning. How is it that we create a process by which each of us locally create high quality, at least 4-star data, and then we integrate so that the same entity, the same people, the same events occurring worldwide can be integrated and we can make the world a big linked data, knowledge graph, as we call it. And this is how we do it. So in Europe, the current state of the art, and also in the US, is that what people do, they create this kind of open data catalog for 6 countries state of the art that they are using here also National University of Mongolia. And what they do is publish data into the catalog, and then you do some analytics, and then you build apps. So if you come to trade, you have like 50 apps where you can do transportation, you can do whatever you want, you can restaurants, events, whatever. But you see, the point here is that, if you do here, here, every time you have to do advanced processing. So if you need to integrate data from restaurants and data from transportation, you have to integrate them here each time again. In Twitter, what you do is say the following. You say instead of just publishing data, we say that instead of so we do data integration, which is when we publish data, not only publish data, we publish data, open data, which are integrated. Let me give you the paradigm. So, for instance, in Europe, it's very clear that the public sector has to be broad for everybody. I don't know if it's here, but so now the issue is you give. Let me give you the paradigm. So you're in charge of these roads. Which road do you build? You build a low quality road or a road with 3 lanes with everything straight, whatever. We did it the same. We can publish data. When we publish data, when it takes a lot of time to drive through them, we're going to publish 3 ways of data. And our decision in this project that we've done in Trade is that we are going to invest in making sure that not only we publish data, but we publish data which can be already integrated, which means we decrease a lot the cost of reuse. Which means that for us, let's see if I succeed, for us, anybody building an app here, like an Android app or an iOS app, doesn't have to do the integration. Which means that the business model for these guys to use data is going to be much easier because you don't have to do every time the cleaning of the data. The public sector, us, does it, the university together with our local government, we decide to do this once for all and set up this methodology. And this is actually what we want to do. So this is where we are, and this is exactly how we do when we do it. Now I'm running very late, so I have 15 minutes, right? And let me briefly explain how we are doing this. Then I can actually show the demo of the tools. Yes. So I hope you're following me. Starting from the vision, from the difficulties, the 5 V's, one example. And I'm showing you this issue where we're trying to integrate data once for all as part of the services that we provide to anybody who wants to use the data so that they can run a business. And we need data because we need jobs. And then we make it we make it easy for people to make a business out of the data that we publish as a public sector, as public sector. So, you see, anytime, let me start from the problem. So anytime, it's very interesting because my wife, when she talks to me about the way I dress, she comes up with these wonderful set of colors that I don't even know they exist. Right? I divide colors by 3, red, white, and yellow. And then my wife says, what about this purple one, or this blue-bellied one, or this whatever. Right? And it's very common. We all perceive the world in different ways. For instance, if you talk bugs, bugs for us, we will say very peaceful it is. I don't know here, but when I go and visit my colleagues in Japan or in China, they give me food. When I go around and there are these kind of pandemics, they tell me that they are dangerous things, or like insects. So you see, there is a fundamental problem that we need to capture in order to solve the data integration problem. We need to have a uniform way by which we make sure that when my wife tells me the color, I understand. When she tells me purple, I understand red, right? And so she keeps saying purple because she would never. If I tell her this is red, she said you're wrong. This is false. It's not red. It's purple. Whatever. So we need this method, or like when I go and talk about bugs. I mean, depending on the context, you need to understand what I'm talking about. And of course, if I'm going to design to be the bug as a software bug, and so on and so forth.
So the issue of the data integration problem is how I make sure that we all talk our own language. You keep talking Mongolian, and I keep talking Italian. And now, by the way, and now we try to mediate in English. But then ultimately, and it's okay, by the way, when you talk Mongolian, why should you waste time talking English when you talk Mongolian? It's like when I'm in Italy, I just talk Italian. But then, all of a sudden, they need to keep talking Italian. It's a diversity for me. But then, if I come here, I need to mediate. I need to mediate meaning. And there is value, of course there is value. There is value for me to be here, I need to mediate meaning. So now the issue becomes how, at a software level, I mean, this kind of process that we all the time do as humans. And this is the problem how we manage data diverse semantic heterogeneity. And this is exactly what we do. And the point where we understood it is that we split the problem of diversity or variety, diversity in the word representations in 4 subproblems. Number 1, language. You talk Mongolian, I talk English. Italian. Not only that, we use the same word for different ways. Number 2, in me, let me just this is in me, I don't like this. Okay, so this is the translation part, and then I want to call lexical names. So, as I discovered when Amara visited me, he told me once that there was this word in English, C word, that he didn't find a good translation in Mongolian. Right? So, and of course, there are a lot of nomadic life words that in Mongolian that for sure they don't have any meaning in Italian because it's not part of our culture. You have to keep into account this kind of stuff you want to translate. If you want to make this mediation step where you understand each other. Now what is becoming more interesting is the following. So, I'm now giving a talk, right? Suppose that my wife calls me up now, right? And says, where are you? Or what are you doing? Now, my wife is back in Italy, and if she calls me up now, I tell her I'm in Ulaanbaatar. I don't tell her that I'm giving a talk. I don't tell her that what I'm doing. I'm an international wife. She doesn't care. But suppose that my wife gives me the same phone call when I'm in Trento, and tells, where are you? I'm in university. Of course, because if I told her I'm in Trento, she would tell me, are you kidding me? I know you're in Trento. So you see, the point is that we use language in a it's amazing we as humans, how smart we are using language. We always use language with the optimal way of using it. So we give the minimum information, which is actual information. So if I'm in Trento, if I know that my wife knows that I'm in Trento, I don't tell her I'm in Trento. I tell her I'm in the university. But if I know that she's in the university, I can say I'm in the office, and so on and so forth. If I'm here, I'm saying that I'm in Ulaanbaatar. If I know she was in Ulaanbaatar, I'm saying I'm in the university. It is important, of course it is important, because we also do this in the data sets. In the data sets, if you have a data set, for instance, if you have a data set for publications, right, within the university, you just put the full details of the publications, and maybe you have details of the position of the professor. You just say professor. You don't say whether it's an assistant or an associate professor. You don't care. You know that this information is another data set. But if I need to integrate later the data set of the professor positions and the data set of the publications, I need to find an agreement. And by the way, many times the Google approach, many times in the past, the Google approach is that this says, I'm providing a single schema for everybody, but this doesn't work in general, because we don't want to force everybody, we don't want to force me to speak English all the time. I want to speak Italian. I want to say to my wife whatever I want. Right? So this issue of the runtime mediation is at the core of providing a data integration strategy which is going to really allow the real integration. And then in data. So for instance, if you took, it was very interesting. In Trento, it was 5 years ago, we integrated the geographical data. We had, I think, 7 data sets about the same data. And now the issue was, which one do you choose? And we started thinking, okay, we choose the one which are more precise. Right? But then we came to the following example. If you are building an application where we discuss about getting this data build an app, an application where you discuss ownership, you want to be very precise. But you not build an application where you want to discuss about what you do with agriculture in a piece of territory. You don't really care. You don't really care. 1 plus minus micrometer, who cares? It's 100 kilometers square. So you see, even the precision in the data, even the way you describe, depends on the purpose. So there is no, for any purpose you have the best data for that one purpose. And if you want to be data integration, you must be flexible also in this. Right? Because each data always, like my wife and myself, pre-compiles inside, since the data is a representation of the world, each piece of data has pre-compiled into it the reason why it was used. Those data were just generated for that one purpose, and they can fit that purpose. And now the issue is how we know that data to make sure that fit other purposes. And what makes it hard? Other purposes that they were not thought about. This is why this kind of mediation of data integration program must be done one time. And then there are viewpoints, which I don't care about. So basically the way we have done it, so basically our technology, what we did, what we're doing now, we built 5 independent applications for each of those levels. So, for instance, we need natural language processing to process sentences. Because you see, not only that, let me say something. In the usual applications, it's not when you in the data in the database, those are data into schema, but those are words. If I write bug inside a database field, which bug do I mean? I mean the bug software bug, I mean the food, what do I mean? So you need NLP even if for data, for structured data. Not only you need NLP, but then you need to memorize the different, the fact that maybe if you talk about body of water, you talk about a river or a lake. And then you need something which will allow you to deal with this approximation of data. And this is what we did. Now I'm running very late, but basically what we did, we built 2 technologies plus NLP, which were basically put them together in these applications. And we have all these applications, and we have basically, we split the problem of semantic heterogeneity in dealing with natural language, dealing with the graphs of meanings, and then later on dealing with the different ways of aggregating data. Now, of course, let me just give you a few examples, because of course I'm running out of time, as usual. So, for instance, we built a graph of concepts. We elaborate work done in Princeton. So we have a database of concepts where we know that the geological formation, a natural relation is geological formation, and then we have a hill or a mountain, which is a continental elevation, which is a natural elevation. So you see the propagation of graphs. Now, we have this graph with 130,000 concepts. We now have it in 9, 10 languages: Spanish, Italian, English, whatever. And we are hoping to have the Mongolian version. And what is interesting is that if we have the Mongolian version with our colleagues here, once we have how the Mongolian write these words, we have the Italian word. This means that the Mongolian word will be automatically connected to the Italian word. What's connected to all the other languages, right? And we now have a Mongolian student working with us, doing a PhD with us, and he's working, building this kind of, by September we're going to want to have 20 languages. And then in 3 times we're going to work with the 500 languages that we are in our target for 5 years, by crowdsourcing. So number 1 is diversity. You need to diversify building this graph. It's a huge graph. 150,000 concepts is on the beginning. We think we have to go up to 1 million. There need to be translation somewhere there. You can read the Mongolian, I don't know which one it is. And we can afford this. And then here with the key point, what we do. Because now the point here, suppose that you've done all of this, but now how do I notion of entity-centric aggregation, which is basically what we do, and I did that in the other slide. We have this idea that if you think about it, anytime you talk about, think of yourself talking about Ulaanbaatar, what do you talk about? You talk about streets, buildings, people, events like today, organizations, the university, the office. Now, it turns out that, and by the way, if you go back to my previous example, they were talking about streets. There are different ways of talking about the restaurant, different ways of talking about the event. And the event, by the way, what is an event? An event is something happening in a location with some people. So basically, what we build, what we do the data integration first with NLP, we get rid of the language. We normalize, we take off Mongolian and Italian, we go to internal form. Given that, which means now we can integrate Mongolian data with Italian data. And then we basically take all the data aggregated around languages. So for instance, and we build, let me say, some kind of knowledge graph. This is what we call the knowledge graph. What is a knowledge graph? It's a graph. It's a graph where each node in the graph is an entity. It can be a person, it can be an organization, it can be a location. Now think that now I come around and so what does this mean? And then maybe I can say I've been to Ulaanbaatar, where Amara and colleagues here work here. There was an event in Ulaanbaatar. You can think of this graph. And any piece of information goes a graph. So now, and this gets to the key point. And we have the technology for this. So this is the key idea. Get rid of the language. You have to do NLP, by the way. You have to do natural language processing. You have to normalize across languages. You have to normalize across descriptions. So you have to get along and understand when you talk bug what you mean. When you talk colors, you talk color what you mean. But then ultimately, once you normalize, get away, taken away all the distorting effects of natural language, put everything in a knowledge graph. And how is it going to go? And by the way, we have knowledge graph. We have like 80 million, 100 million data sets. But this is the way we want to do it as follows. We would like to have the global picture that what is, we want to build the knowledge graph of the world. We are very optimistic, but I mean, since you're a professor, if you're not optimistic, if you don't dream, what do you do? I mean, as a professor, I mean, otherwise you go in the company and make much money. So then we build. So what is the point here? We build for each language all the words and the collections of meanings. We are doing now, as I said, with the 9 languages, going to 20 languages by September, and then we're going to grow. And by the way, this project is already going. We have a few thousand words in Mongolian, not too many, but we've started. And then what we do? We build one knowledge graph for Ulaanbaatar. We build one knowledge graph for Trenton. We are now going in Bangalore building the knowledge graph, another one in Portugal, and each of them building their own knowledge graph. See, if you think about Ulaanbaatar, what is Ulaanbaatar? It's a place with people, with organizations, and they're all connected. And then there is the other piece of graph, which is all the connections, like Fausto and Trento living there. But then there is a link result from Fausto and Trento to National University of Mongolia. Actually, we're not linked, so we link from National University of Mongolia. And so all of a sudden, there are these kind of dense graphs locally, but then they get connected across languages. And this is exactly our approach. And our approach, and ultimately, to go back to the original issue, the point is that we, and therefore, at the system level, split the problem of data integration in 2 parts. Part number 1, how you integrate languages across languages and across schemas, across the different applications, and then how you store data in the interoperable, which is such that the Fausto Giunchiglia here is the same Fausto Giunchiglia here, and the same for Amara and others. So basically, with this I conclude, and I went very late as usual. If I have questions, otherwise I can show you the demo of the system working. But the key point here is, let me just give a brief sum up, is data are very important. Open data are particularly important because they're going to provide the infrastructure for any kind of data. We believe that the way to go for open data is to have this kind of mixed local and global approach where each institution, each aggregation of people, each community builds their own open data and then we collaborate to build the worldwide knowledge graph. Thank you very much.
Thank you very much, Fausto Giunchiglia. Any questions?
Interesting about the multi-dimensional real-time open data.
Yeah. First of all, you have to decide what you mean by real time, because multi-dimensional is not a problem, because for us each dimension is just one dimension of expansion of the graph. And then of course, on the other part you can do analytics. Now, the real time depends what you mean by real time, because real time in transportation can be an hour. Real time, if you're driving a plane, is milliseconds, or even less than milliseconds. I don't believe that the kind of approach that we are doing allows us to be as real time as like an hour, because we are concentrated on applications where we don't have these real time pressures. And by the way, let me say also that in those applications where you have not real time constraints like the driving plane or whatever, I mean, you don't do it's a different application from open data. So I believe that in most applications of open data, there is no need of real time. But let me say, however, that I don't think this is a defect of the approach, because if you have like a real-time application, like transportation, some issue of transportation when an earthquake is still then I think the way to do it is that you first integrate the open data, you do offline, but then for the specific like earthquake management, like civil protection problems, you just build the vertical data. You see, open data, you have to see the open data as an approach where you integrate data so that everybody else can do whatever they want to do. Even considering the really real-time applications, which are whether really real-time applications should be done with different technology for open data, technology which is specific to the specific application domain. So,
Okay, then thank you very much again for the interesting presentation.